Hi everyone, thanks for joining our webinar today. So I'm Nur Salawati. I'm the technical support specialist at Bizit Systems. So Bizit Systems independent representative Minitab for Malaysia, Singapore, Batam, Indonesia, and Philippines. So today's topic is predict failure, optimize the cost, unlock the power of the tree-based model. So we have a few housekeeping notes before we begin. We have a Q&A session after the presentation. So please submit any question you have and we will try to do our best to answer afterward if have time. If no, afterwards by the email. So we recommend viewing this webinar on your laptop or PC for the best result. So please fill out our survey before you exit the tab. This survey will help us to improve the quality of our upcoming webinar. So we also record this webinar and upload to our website www.bizit.com and YouTube channel, Minitab Malaysia and Singapore. So there's no problem if you miss anything or want to review afterwards. So Minitab was developed in 1972. Okay, so today Minitab in market for more than 50 years. Since more than 50 years, we also have other product like Minitab Connect for the data transformation and the dashboard. We also have the Suffolk Predictive Modeler. It will be the machine learning and predictive analytic. But now some of other algorithm inside the SPM available in statistical Minitab statistical software. And we also have extension from that. We also have the Minitab model ops. They will have you try and implement your own models from your machine learning and predictive model. We also have the education hub. It will be the online training, consists of few models like statistical process control, statistical quality control, regression, design of experiment, and predictive analytic module. We also have the real-time SPC. The one is the, I think it will be more reliable right now. For those I do it the SPC, it's something like you can monitor and then maybe they will alert in the right real time, allow you for do some action when your process is not stable or out of control. And then we also have the Minitab Engage is for idle execution project. And then inside the Engage, we also have the dashboard. And we also have the Minitab workspace. It's something consists of the lean tools, let's say 5S, VSM, and others linked or we call it that one is a compilation of the template so available in the Minitab workspace. So if you interest further to know others products, so feel free to contact us and we can provide the demo and each for the product. So the one is the available tools available in Minitab statistical software is I think most of our we know about the Minitab is regarding the quality side. It's something like MSA, control chart, capability, tolerance interval, and so on. We also have the for reliability engineering. Okay, for those who want to study about the MTTP, okay, so that one is the one of the tools is good for you to study about the reliability engineering. It will support you in terms of output and so on. And then we also have the product development. Is one of the famous or most of the researcher use is the design of experiment. Okay, we will consist of many type of the design itself. One of that is response surface method and so on. We also have the business analytic. It will be consist of the statistical modeling. So today one of the modeling we use is a classification and regression tree, and then we also have the time series and so on. So we also have this kind of the process validation. Okay. And then, of course, since we have many tools available in Minitab statistical software, so our customer coming from various industry, it's not specific for the manufacturing only. We also have for services, for academician and healthcare and so on. So our topic today is we try. Okay, I think last month, for those follow our webinar, we see on the regression and the mass, they will one of the tools will help you to prevent the defect in waste, or you want to do something prediction. But this top today is will be consider that will be the extension or alternative method when you facing with the different side of the data set. Okay, or maybe you are interest is beside using the equation, maybe you want to look on the visualization. So today is a tree-based model. So in the tree-based model for Minitab, we consist of a tree algorithm. It will be the classification and regression tree. And then we also have the random forest. We also have the TreeNet. So for today's session, we try run some of these example for the classification and then for the regression example. Okay, classification here is refer for your data type is your response will be the test data set is accept reject is a binary or multi-binomial approach. Let's say your scale 1, 2, 3, 4, and 5, so on. And then if let's say your response, let's say for today is a cost, is a numeric, so it will be goes for the regression example. Okay. So today, hopefully in 1 hour, you can get some idea on this part for the tree-based model. So actually tree-based is something like we use if then rules to create the prediction from one or more decision tree. So I think last time during the secondary school, we already use this kind of the approaching. Okay, so for example, today I just give you a simple analogy. Okay, maybe it will be give some idea after this what's mean by the tree means. Okay, so for example here, we try with the simple case, what we want to do this weekend. Okay, so of course, we can have a list of the question to answer for this question. For example here, maybe the first question you will be need to answer here is something like, do you want to spend time indoor or outdoor? Okay, so for this part, you do this kind of the decision is indoor or outdoor. So can another question coming? Maybe you will give some idea. Are you in the mood for the something active or relaxing? So you further with this thing with the relaxing and active. Okay, so from this part, maybe you have another question you need to ask, you need to answer it. Okay, so maybe it's a would you prefer do something alone or with the friends or family? So something like during the reciting, maybe you want to read a book, it's a lonely activity. Maybe you want to see some watch a movie with your family base, or maybe you have others idea on this part. So this kind of approaching, it will be goes for the tree-based model. So by right, in order to do the tree-based, you need have a consider a few of question before you get some answer on this part. Okay, so for this part, you can get, okay, is it in the door, you choose the relaxing, maybe the right thing, you can do the read a book. But if let's say you are outdoor person, okay, but you want something active, okay, so maybe you can go for the hiking, or maybe you can have another consideration to do this part of the tree diagram. Okay, so this kind of the tree diagram maybe is useful for you for manufacturing or others industry for us to making decision. Okay, and then maybe you want to optimize your process, and then maybe you want to predict the outcome. For example, here is you are coming from quality control, so you want to identify the potential causes of the defect in the product. Maybe before this, you using the brainstorm, approaching your root cause analysis, FMEA, something like one. Okay, maybe from this webinar, you know about the tree diagram, but you have a need, have some big data set in order to use the tree diagram. And for example, another example maybe for the predictive maintenance, okay, we always act after the machine is a failure. But now, using the tree-based or predictive analytic, maybe you can act before your machine is a breakdown. As we know, when the machine is breakdown, you can increase your cost, you can lose something that one is not so good for your uh, uh, company. And then maybe you want to see the process optimization. Okay, maybe you want to see about the factor most influence your production quality or something that one. So all these things is example how we use the tree diagram in your industry. Okay, and then of course we try do the predictive analytic, since the tree base is not only the speed to the not only the speed to answer, but also provide the accuracy, and maybe it will be easy of interpreting. Okay, so we will go after this. And then another thing, maybe compared to classification, classic statistical method last time we do for regression. Okay, I think about last 2 years we do some survey, okay, about the regression. Why the engineer is not use the regression in their analysis. And then one of the highest answer, regression is not more high accuracy. Okay, and then regression have something like you need to fulfill the assumption in order to use the regression or the equation, the model. So that's why we uh, try introduce new approaching. We call it, that one is the tree diagram. So this tree diagram is convenient when your data set is a large data set. Maybe your variables, a lot of variables, and then maybe your rows of number of your data set, it will be the bigger. And then of course, maybe you're using the sensor, you combine them together from your customer details with your mission equipment, with your material itself, you combine them together, maybe have some messy data, you have a missing data, maybe you have a random outliers, and then of course you can face it with the non-linear relationship. It's not the straight line. Okay, I think a lot of the real case study I face it, I see then not the linear relationship, there will be the non-linear relationship. So maybe all these things, it will be good, let's say, for the tree diagram. Okay, and then for the tree diagram is available for both response, whether it's classification and regression response. Okay, maybe before this regression is for the numeric, but if let's say you have a yes or no, you can go for the logistic regression. It's a little bit different. Okay, but for this case, you can use the cut, but cut for classification, random forest for classification, TreeNet for classification, and then cut also for the regression. random forest for regression, and then TreeNet also for regression. Okay, but I have something behind that. In technical part, it will be different how they calculate the tree stuff. Okay, so here is one of the algorithm for the tree-based predictive model available in Minitab right now. Okay, for those are using the basic, I think I opened the Minitab easy for you to see it, where you can get the uh, cut, okay, predictive analytic. You go for the step once you launch your Minitab. Okay, I think it's starting with the Minitab 19. You can see the predictive analytic. You go for the start, you will go for the predictive analytic, and then you will see cut classification, cut a regression. It will be the basic. But for those already subscribed to do with the, we call it the predictive analytic module, you will see the TreeNet classification, random forest classification. You will see the TreeNet regression, and then you will see the random forest regression. And beside that, they also have the marks. And then the other thing is interesting part, they also have the automated machine learning, which is they will help you to choose which one is the best for your cases. Okay, you do some complete the simple box, and then Minitab will run all these algorithm, and then Minitab will choose what will be the best for you. Okay, for the automate machine learning. But all this, but you need have the additional cost for the subsidy for the predictive analytic module. Okay, so no worries. We start with the simple, the basic. Go for the step. You will see the predictive analytic, where you see the card classification and the card tree. Okay, card regression. So we go back to this part. Okay, so you will see that what is the cut? Cut means that classification and a regression tree. So cut actually is developed by the Bryman, Freeman, Awesome, and the Stone in 1984. And then cut is a split. Okay, is the create a set of yes or no. It's a low and high. Okay, let's split the response, okay, variable into the partition based on the predictor setting. So the line split will be the predictor setting, So also for this part is the cmain and then the cmain. So for this part, classification tree is goes for the percentage. You will see the in the percentage, but for the regression, you will see on the mean and then the standard deviation. Okay, the statistic inside the tree it will be the different, but how to interpret it will be the same. Okay, and then the cut, of course, no need to check the assumption. No need to check your residual. Cut is easy to interpret. So you will see this one is the visualization rather than equation. And then maybe cut is available when your data set is a medium. Okay, data set. Maybe a lot of variables, more than 10, okay, or your row of your data set will be more than 1K, so it's available for the regression tree. Okay, and then here is some terminology in the cut, how cut is works. Okay, so we start with the simple one. The one is the nodes, so we call it the one is the nodes. Okay, and then here is the first one here, we call it the root node, is the node at the top of the tree. Okay, and then start from here, they have the splitter. Okay, the split by this part, the decision rules that define how the nodes is partitioned. And then of course they have the tree splitter here. Okay, the one is the weight. Weight is a less than. Okay, and then here is a weight more than value. So yes or no, low and high. And of course, they also have the terminal node. Terminal node means that a node has no sub branch. Okay, so in this terminal node, they provide you the mean and then the standard deviation. The mean here we consider it will be the prediction. The mean fit in the mean of the terminal node. So by right, these three, okay, these three have the three terminal node. have the three decision rows. This decision row is coming from the first row. If the weight, okay, for this part, if the weight is less than or equal this 396, then the predicted value of manufacturing cost, it will be goes for 79. Okay, and then the second row here is coming from weight more than 396, and then the speed is less than 50. The predictive cost, manufacturing cost, it will be the 233. And then here, it will be the terminal node 3 when your weight is more than 396 and then your speed is more than 60. So you will get the mean AVD 147. Okay, so this one is how we get the rules inside the tree. So you can imagine the one is with the simple, with the tree. So if let's say you have 10 terminal nodes, so meaning to say that you have the 10 decision rows you have. Okay, so from here, maybe you can compare, which is you want interest with the less number of the manufacturing costs. Okay, costing you want the less number. So it will be goes for the terminal node 1. But if let's say you interest with the terminal node with the highest number, so you will go for the terminal node 2. Terminal node 2 coming from the weight is the bigger and then the speed is the lesser. Okay, so this one is how we can get some interpreting from the our tree. The one is considered one tree only. Okay. So we try with this one simple case study about the predicting machine failure. So maybe you can merge your data set is from your process itself, from your metric itself, from your machine itself, and so on. So you can combine together, and of course, you already use some fishbone diagram. Okay, it will be full for you. Okay, it's easy for you to make it in one data set. Okay, you can study about the relationship, you do the FMEA, is something good for you to do this part. And then maybe you combine all of them together and then you get the response. So all these things, maybe you can measure by the device, you can collect the data set. Maybe that one is something, not the only one day data set. Maybe you combine from the 10 years data set. Okay, it's a historical data set. So you combine them together. So here is something like you have a 4 predictor. This is the air temperature, your P temperature, your rotation, speed, your torque, and then your machine failure. The machine failure is 1, and 1 is a failure, 0 is a normal. So here is they want to predict, okay, the probability when the mission is a failure. When is it when the torque is a biggest number, or when the torque is a lossless number, or maybe the first thing they want to see that which one is the most important here is the torque or the rotation speed. Most important into the mission is a failure. Okay. So we try open this case study. Okay. So one of this one. So you want to see that this study, the variables, I think it's not so big. Okay, but the rules of the variable is so big. So you can go for the right click worksheet information. You will see that this part. That one, it will be only this part. I think yes, we sorry for that. I think I need to open the new data set. It's not so big data set. It will be less than 1K. I think cut is not so good when you just only 5. Okay, just only 5 variables with the 200 something row is not so big data set. Okay, so for this part, I go for this worksheet information. We will see that a lot 10K. It will be big data set. It will be the good cut. Okay, so for this case, it will same for, I think this one, I just for the cell, clear the formatting here also, the clear formatting. Okay, so for this part, we try do the some cut, the simple tree. Okay, one tree. So you go for the start, you go for the predictive analytic. So here is a mission is 0, 1 binary. Okay, binary response. So you go for the classification. So here is a binary response. But if let's say you have more than 2, so we consider it's multinomial response. So for this part is 0, 1. So we go for the binary response. Our response is the mission failure. Okay, so our event will focus on the 1 is the failure. And then here is continuous predictor, or this part it will be the continuous predictor. So the other part is the validation. So by the default, Minitab consider more than 5K. So Minitab using the validation with a test set. Okay, but if let's say less than 5K, Minitab consider is use the K full cross validation. Okay, validation is something like you split your data into 2 partition. It's one part it will be the test data set, another part will be the train data set. Train means that you build the model, and then from there you test your data set. So this part is a validation method. Okay, and then you click OK, and then you click OK. So Minitab will provide you the 6 nodes cut. Mean that 6 terminal node just now. Okay, and then of course they provide you the binary response information. They provide you this part also. Interesting part, okay, is the terminal nodes, and then here is the misclassification cost versus the number of terminal nodes. By right, Minitab give you the optimal tree here with this the 6 terminal node. Okay, but of course you don't want to see here, so maybe you can select an alternative tree. You want to see another approaching, so you can go for the alternative tree. So here is the 6. 1, 2, 3, 4, 5, 6. Okay, so you will get the 6, or you can go for this part. So from here, you will see the 6 terminal nodes. So maybe you want to interest with this terminal node 1. Okay, and then here is terminal node 2. It's a concept from this rotation speed, your air temperature, your torque. Okay, and then here also for this part, we want to see the bigger number of this part is 50%. Okay, and then here is same with the 50%, 50%. Maybe you will go for this part, terminal node 3. Okay, it will be the 1.0. Okay, 60% is will be the 30% will be the failure mode. Maybe it's coming from rotation speed and then your temperature. Rotation speed value is the less or equal to 1336. Here is temperature is more than 300. So they will get this part, percentage of this is almost 39%. Make sure it will be the failure. Okay, so you can go one by one. This one is the optimal tree suggested by the Minitab. But of course, maybe you want to see the more this part. So you can go for the 61 terminal nodes. You want to see the splitting about this part. And then of course, they also have give you the model summary. Since that one is a binary, we look on the ROC. Okay, so the ROC is give you 0.5 up to 1. 1 is the good. Okay, it's classified between 0 and 1. So here is almost okay. Almost okay. Okay, since they're more than 0.7. Okay, for the test. And then here is your relative variable important. Meaning to say that the thought it will be the most important predictor in order to assess the mission is a failure or no failure. Most impact into the top. Okay, and then the second part, it will be the rotation speed and so on. So, but for this relative variables important, they give you in term percentage. Okay, but doesn't have any guideline up to percentage 0.7 or doesn't have any guideline. It will depends on your preference for the cut. Okay, and then of course, for those are using the classification, maybe you want to use the confusion matrices also available. You have to predict the classes, okay, your actual class, your you also have the misclassification Okay, and then here is actual pipe, and then here we have the ROC. Okay, we also this again chart and so on. So all this one is available for this pipe. Or maybe we need to try make it simple. You can right click. Okay, you can go for the highest 5 optimal nodes. Okay, or maybe this pipe, since the classification has optimal node, maybe after this we can use the regression. You have the 5 less highest number of the 5 and then the lowest number of the 5. So based on these 5 nodes, okay, the one it will be this pipe. Okay, or maybe you can go back to the dialog box. Okay, you go for the result. Maybe you want to see study about this pipe. Maybe the best or the worst or the best and worst. Maybe you want to see the effectiveness of classification by the K terminal. Click OK and then click OK. So Minitab provide you another additional thing here. This pipe effectiveness of this. Okay, so the based on this five, the best 5 terminal nodes is the terminal node 2. Okay, and then here is the class test. We use the for the test here is the event probability this part, and then for this part. After you satisfy with this part, okay, maybe you can do the prediction. Okay, after you satisfy with this with the 6 nodes, so you can do the predict. But of course, in order to get the most, the best model, okay. So we facing with these 2 things here. The first one, you must have the most accurate predictive model, okay. And then of course, just now you are see about this 80%. But the best, it will be the 100%. Another 20%, maybe you can increase with the another algorithm. Okay, and then another thing is maybe you facing with the variability of your variables. Okay, not only consists of 2 type, maybe 10 type, 20 type, 20 dimension, a lot of a multivariate data set. Okay, you face it with this part. So that's why you need to try do another thing, another algorithm beside the cat. We call it, that one is a random forest. Okay, cat just now only 1 tree. Okay, we believe that one you have a more than 1 tree, your accuracy will be increased. Okay, so the method to get more tree, we have a lot of method. One of the method is we call it ensemble of the tree, which is random forest. It will consist of multiple tree. Okay, for example, here you have your X data set. Okay, you create 1 tree, cut first, cut 1. Okay, and then cut through. You go back your data set into your data set. You create another tree. Okay, after you create another tree, you pull back your data set, and then you create another tree, and so on up to how many data set you have. Or maybe you have a fixed how many tree you want, and then they have, maybe you can go for the majority voting for classification. If let's say for regression you have averaging, and then you will get the tree here. So in another cases, we believe that more than 1 tree, the accuracy, it will be the highest. Okay, the difference is how they get it, make it multiple tree. So one of this part, we call it the ensemble of the tree. Okay, so for the random forest. So we try with this one case study. Okay, I think I used the same case study. Okay, same case study just now. It's about the mission is a failure with the 4 predictor. So you will see that the multiple variability inside the air temperature here is a rotation speed, also multi-dimension of the tree variability. Okay, so how to get it? The random forest, you go for the predictive analytic, you will go for the random forest. But this available once you subscribe for the predictive analytic model. So you go for this part, the same, the dialog box will be the same just now. Okay, so the continuous, this part, it will be this part. So you will have the validation, and then you click OK. So Minitab will generate the random forest for you. So in this random forest, so the sample will be 300, okay, and then the variable here is information. Of course, they also have the misclassification versus the number of the tree plot. So they will consist of 300. They will build up to 300 tree. Okay, and then they provide you the 0.88. Just now is 0.87. I think it's 4. So it will be increased. Okay, and then they give you the relative variables important. Is here also the thought it will be the most important predictor impact into the mission failure. So something happen, the thought they will be impact into the mission failure. So of course, as engineer, okay, you want to know about the what is the value. Okay, it will be the impact into the mission. You just not stop. Okay, you know about the thought it will be most important. But now, what is the value for the thought it will be more impact into the mission will be the failure. Okay, so you can get another investigate for you in order to satisfy your requirement also. Okay, just not only for this part. For your information, random forests only have this part. Okay, and then beside that, the ROC will be the increased value of the ROC here. Okay, one of the thing. That's why another algorithm, Minitab decide to add, we call it the one is the TreeNet. Okay, and then Minitab believe that the TreeNet will be the high accuracy rather than other three. Rather than cut, rather than random forest. Okay, but for the TreeNet, the also multiple tree. Okay, they will generate the multiple tree. Okay, but with the smallest tree sequentially. This means that they build the tree. Okay, they build the tree from the residual. After build the tree from residual, they build another tree from residual, feed residual, and so on. So each subsequent tree correct the error of the prior tree, and then the final tree by adding all the correction here, they will get the tree. Just now the random forest, you take it, you create, and then you get the average. But now for the TreeNet, the tree is coming from your residual, your error. Okay, so you get from the residual, you sum all the residual, so you will get the TreeNet multiple tree also, but the different multiple tree approaching. So we consider that the TreeNet it will be the fast and efficient. And then of course, inside the TreeNet, they provide you the partially dependency plot. And then they have the interaction control here. So what mean by the partial dependency plot? It's something like you can know just now from the random forest, you know about the thought it will be the most important, but what is the value? What is the minimum value? What is the maximum value? What is the range of value for the thought it will be more impact into the machine failure? So into this part, Minitab with the TreeNet algorithm give you the partially dependency plot. Okay, so how to say that? We go back to the part, this part. Okay, I will use the same case study. Okay, but now I will try with the TreeNet. So the same, go for the predictive analytic. You go for the TreeNet classification. Okay, for TreeNet, you fit the models. Okay, you fit the model. Your response is the machine failure. Okay, the dialog box will be the same. Here, also the select all this part, and then you click OK. So Minitab will generate the multiple tree. Okay, multiple tree. So this part is the tree here, up to 300 tree also. Okay, they have the training and the set data set. And then, of course, you see the ROC will be increased 0.89. Just now is 0.88. Okay, now it will increase 0.89. And then the relative variables important is at top here also. And then you will see that the differences between the air temperature and the relative speed just now. we compare after this. And then, of course, also the same, they provide the confusion metric, misclassification, and you want to see on this part. Okay, you want to see the partial dependency plot. Okay, so we see on this part, you will see that, okay, maybe the first time you see, okay, your hypothesis testing before you run the experiment. Okay, as an engineer, I think you already have your hypothesis testing. Okay, so we see that based on this part, when your torque increase, the value of your torque increase, okay, your value of the machine failure, the probability of the machine failure, it will be decreased. Okay, so increase but decrease, but at the same time they will increase, and then the probability of your failure, it will be the increase back. So inside the TreeNet, they provide you this information. So you can drill down one by one of your predictive. Okay, you can get the one by one of your predictive. And then of course, you want to further, is it is correct or is true or not for this part? Maybe from here, this maybe it's a lower number. This one is the highest number. Okay, it will be the lowest level. This one is with the highest level. And then you come out with your design of experiment to rerun back your experimental. Is it this value? It will be most important into the air temperature, more impact into your temperature. So in other case, tree diagram or predictive analytic, it will be some tools, additional tools for you before you run the actual optimization, your DOE, your design of experiment. So it's some supplemental tools before you run your experimental design. Okay, I think it's more valuable on this part. So you can find one by one for each of these predictor. So for the partial dependency plot. Okay, of course, predictive analytic, maybe you can go for this part. Okay, I just open it. Your cut here is the random forest here. Okay, so this one is a TreeNet. Sorry, I go for this part. Easy for you to see it. Okay, so for this part, you will see that the value of the R, it will be increased. Okay, it will be the increase. Value of the R will be the ROC, it will be the increase. Okay, so from here is 0.84. Okay, simple tree, only one tree. Here is consists of 303. Okay, they will be get the 0.88. Okay, and then here 300 also, but different, they will get the 0.89. Okay, something that the TreeNet will give the highest value or the highest accuracy rather than the others algorithm. So maybe from here, okay, you have a new data set coming. Okay, so you can do the prediction. So you go draw up for this part, you go for the prediction. So in this case, for the prediction, maybe you can go enter one by one. Okay, or maybe you can enter individual one by one, or maybe you can use the worksheet, okay, to do the prediction on this part. Okay, for example, here I try with this one. Okay, I need to copy it first. This part. Okay, go back to this. Sorry, go back to this part. I get the new data set. So imagine now I get the new data set coming, okay, with this predictor. So I go for the predict. So for this part, I just put for the air temperature. Here is a P temperature. Here is the rotation speed, and then it's a torque. And then of course, gives the result. Result will be inserted into this worksheet. Okay, you click OK. So you will get the P event on this part. And then the class is a terminal node. Okay, class 1 or class 0 or 1 for this part. So this one is the probability. The machine is be the failure. Okay, so they will get you the new result for this part. Maybe from here, you can play around with the others visualization to drill down for this event, okay, for the predictive value to make sense of this study. Okay, so this one is how we use the tree diagram from the one tree diagram, and then we go for the random forest, TreeNet, and then of course stay with this part. I think most of our interest of this on this part. Okay, I think most of the engineer most interest on this part. So how they do this, they will help you on this. Okay, they will help you on this part. So this value you want, interest into this value, interest into this value. For the splitting value, you interest more on this splitting value. Okay. So this part is for the classification. And of course, you also face it with the regression side. So your response, just now is a mission 0 and 1. Maybe you face with the yield, okay, is something measurement, your diameter, your strength, injection molding strength, okay. And in this case study about the costing, okay, the one is one of the board cut manufacturing, okay, they collect them together with the star, the plan, the segment, and then you will see that there are a lot of this. For example, I go for this conditional formatting. I just want to show you the not only one segment here, okay. So you can go for the mesh with the list, okay. You will see that not only one. So maybe you can go here also, not the e-commerce and protein. Maybe you have the others market is available. And then we also the weight, the speed, the rate, efficiency, step, time, your metric tone, and then of course your cost will be the our response. The rest it will be the predictor. So first thing you want to know about the most important predictor into the costing. Okay, of course, this part maybe is applicable when you face it with something like your customer coming to you. Okay, so I have this packaging, the weight is this value, with the dimension is this value. So what is the cost for the packaging? So it's something like you can use for this part with the based on the prediction model. Okay, so for this part, same. Just now, we can go further step. You can go for the predictive analytic. So now it's a regression. It's a regression since our response cost of manufacturing is the value, is the numeric. So you go for the regression. Okay. So the same dialog box is a response. You go for the response. Here is our continuous. Maybe here it will be the categorical predictor. Same also have the validation part, this part, and then here you click OK, so you will get the card. Okay, so you will get the card with the 30 notes. Okay, means that you have a 30 decision rows. Okay, so here you will see that a lot of this part. Okay, you can see this part, a lot of things. Okay, this part maybe you can go for the highest with the highest cost. Okay, the one is a 5 notes highest cost. Okay, here is the note 24. Okay, the mean cost is about the 400 something. It's coming for the weight, this value. Okay, and then here is the weight, the speed, the weight, and the plan here. Okay, so you will get this value. So from 5, maybe you can compare it with the highest value from the 5 value. And of course, maybe you want to see the lowest mean. Okay, the lowest mean of this part. Okay, here is this part. The median of one is conceived from the weight, the speed, and then the weight, and then the plan here. And of course, you can go one by one. Okay, you want to study one by one. Study, you can just only click on this part, you will get these rows. You go this part, you will get the rows, and then you can copy and then paste it into the output or into the words or something that you want to do the reporting purpose. Okay, and then of course from here you will see that okay, the weight it will be the most important predictor into the cost. Okay, of course, you want to see what the level value of the weight. So you can go back to this part. Okay, you can get to this part. So of course, use this part is R squared. Now regression, you will look on the R squared. So 80 3 is we the good more than 0.7. But of course, since you have another algorithm, so maybe you can run with the TreeNet or random forest. Maybe I go for the TreeNet regression, fit the models. Here is the cost. Okay, here is the weight, all this part. Here it will be the style of this part. And then you click OK. So you will get the TreeNet model. Okay. So you will get TreeNet model, and then of course you will look on this part first. The R squared is a bigger. It's at 19 okay, 96, okay, rather than just now is 80 something, okay. And then of course the weight, it will be the most important, and of course we want to see on this part, okay. You want to see on this part. So by right, okay, increase the value of the weight will increase the value of the cost. Okay, so maybe something like straight line, okay, for this weight. And then here maybe you can go for another rate. Okay, so another rate have something, not the straight line. Okay, it's a non-linear relationship. Maybe increase first, okay, decrease, and then up, down here to decrease, decrease, and remain. Okay, so you cannot say that, okay, rate will be increased, the value of the cost, it will be decreased. So not directly. So maybe have the relationship between them. Okay, from here, maybe you can study about the maximum number, the minimum number, or the range between the rate number. It will be the good for the cost. Okay, on this part. So I think you will get something idea on this. Okay, I already explained about this, the prediction also for this part, and then the kite. So you can see the biggest tree. Okay, and maybe the biggest tree will get you the more decision rules. Okay, for you. And then we also the model inside. So this one is the PDP plot. Okay, and here is a predictive. They predicted manufacturing cost. Maybe sometime your customer coming and then they want to see the prediction cost. Okay, so they will have the weight, the speed here, and then the rate, the efficiency, the setup time, and so on. And then the predictive value of predict cost for this part is 110. Okay, 110 for this part with this value. So another customer coming, so you will get the fit value. You can get another value and another value. So not need only by the gut feeling only. So you now you have your models, you insert the new data set, and then you can give the accurate of costing estimation for your customer. Okay. And of course, this one is the tree-based natural extension. Okay, just now I mentioned from regression and binary logistic regression. Maybe it will be useful for determining the key drivers, and maybe you want to do the predicting what will happen the next before the process is not occur. Okay, so before that happen, so you already know about that. And then I think now you already go for the smart factory. You using sensor or this thing, technologies. So you maybe your data, it will be the big data set. Okay, so that's why we advise or convene you use the tree-based model. Okay, so because tree-based is faster, maybe more accurate, and then save your time, and then of course they will uncover your relationship. Okay, for this part. So after this webinar, maybe you can try with the simple cut first. For those you already have the subscription for Minitab statistical software, and then of course you want to see more on that accuracy, maybe you can back to me or back to us, and then maybe we can do some projection for you using the TreeNet, and then your random forest you want to try with this bike. Okay. So if you have questions, so type into the chat. Okay, if no question, or maybe after this, right, you have a question after you try with the card, so let me know. So you can email to us, to minitab@bizit.com, or to me and uur.sulawati@bizit.com. Okay, so thank you for your time and attention. So to learn more about Minitab, so please contact us by visit www.minitab.com or www.bizit.com, or email to us to minitab@bizit.com. So to get some tips and tricks on our Minitab product, so please follow us through media social like Facebook and link at the Minitab Malaysia and Singapore. So to access back our previous webinar, please subscribe to our YouTube channel, Minitab Malaysia and Singapore. So really appreciate if you can fill out our survey in order to enhance our webinar session. So see you next time with the different topic, and happy learning.